This is SpaceTime, Series 22, Episode 90. Coming up on SpaceTime. Have scientists detected a mysterious fifth force in nature? A record-setting X-ray burst? And rewriting the textbooks on the origins of globular clusters. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists with CERN, the European Organisation for Nuclear Research, are investigating fresh claims of the detection of an unknown particle that could be a carrier for a fifth force in nature. Back in 2015, a team of scientists led by Attila Krasnowski from the Atomic Institute in Hungary spotted an unexpected glitch or anomaly in the nuclear transition which could be explained by the production of an unknown particle. About a year later, theorists suggested that this new particle, if it exists, could be evidence of a new fundamental force in nature. The standard model of particle physics, the very foundation stone for our understanding of the universe, currently lists four fundamental forces. There's the strong and weak nuclear forces, which are mediated by gluons and W and Z bosons. There's electromagnetism, which is mediated by the photon. And there's gravity, which, if it really is a force, rather than just an effect of mass on space-time, would be mediated by the yet-to-be-found graviton. The characteristics of this hypothetical fifth force would depend on the theory being advanced. Many are postulating a force roughly the strength of gravity, which is much weaker than electromagnetism or nuclear forces, with a range of anywhere from less than a millimetre up to cosmological scales. Another proposal is for a new weak nuclear force, again mediated by W and Z bosons. The suggestion of a possible fifth force sparked a direct search for the mediating particle by the Na-64 collaboration at CERN. However, despite exhaustive efforts, they were unable to find any trace of the particle. Now, a new paper by the same Hungarian team has reported yet another anomaly in a similar nuclear transition that could also be explained by the same hypothetical particle. The first anomaly was seen in a transition of beryllium-8 nuclei. This transition emits a high-energy virtual photon, which then transforms into an electron and a positron, the antimatter counterpart to the electron. Examining the number of electron-positron pairs at different angles of separation led the researchers to find an unexpected surplus of pairs at a separation angle of about 140 degrees. Now that contradicts existing hypotheses, which predict that the number of pairs should decrease with increasing separation angle. The Hungarian team reasoned that this excess could be interpreted by the production of a new particle with a mass of around 17 megaelectron-volts, which they named the X17 particle, and which would transform into an electron-positron pair. The new anomaly also arises from an excess of electron-positron pairs, but this time the excess is from a transition of helium-4 nuclei. In this case, the excess occurs at an angle of 115 degrees, and it could also be interpreted by the production of a particle with a mass of about 17 megaelectron-volts. Importantly, it lends support to the earlier observations, and it strengthens the idea of a possible new elementary particle. Scientists with the Na-64 collaboration say that while the anomalies could be due to a completely new particle, they could also be just as likely caused by some sort of experimental or nuclear physics effect. To test the hypothesis that the anomalies are indeed caused by a new particle, both a detailed theoretical analysis of the compatibility between the beryllium-8 and the helium-4 results, as well as independent experimental confirmation, would be critical. The Na-64 collaboration has been searching for the X17 particle by firing a beam of tens of billions of electrons from the superproton synchrotron accelerator onto a fixed target. If the X17 particle does exist, the interactions between the electrons and the nuclei and the target should, at least on some occasions, produce this particle, which would then transform into an electron-positron pair. The problem is the collaboration has so far found no indication that such an event's taken place. But its data sets allowed them to exclude part of the possible values of the strength of the interaction between X17 and an electron. So the team are now upgrading their detector for the next round of searches, which are expected to be far more challenging. Among other experiments that could also hunt for the X17 in direct searches is the L8CB experiment, one of 4 particle detectors around the Large Hadron Collider, the world's largest atom smasher. By 2023, the L8CB experiment should be able to make a definitive measurement to either confirm or refute the interpretation of the anomalies as arising from a new fundamental particle. In the meantime, experiments such as Na64 can continue to chip away at the possible values of the hypothetical particle's properties, with every new analysis bringing with it the possibility of a new discovery. You're listening to SpaceTime. Still to come, a record-setting X-ray burst and rewriting the textbooks on the origins of globular clusters. All that and much more still to come on SpaceTime. Instruments aboard the International Space Station have detected their brightest ever X-ray burst. NASA's Neutron Star Interior Composition Explorer, or NISA telescope, picked up the sudden spike of X-rays on August the 20th. The burst, reported in the Astrophysical Journal Letters, was caused by a massive thermonuclear explosion on the surface of a neutron star or pulsar that had exploded long ago as a supernova. The X-ray burst, the brightest seen by NISA so far, came from an object named SAX J1808.4-3658. The observations reveal many phenomena that had never been seen together in a single burst before. Even more puzzling, the subsiding fireball briefly brightened again for reasons astronomers can't yet explain. Peter Boult from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says the burst exhibited a two-step change in brightness which he thinks was caused by the ejection of separate layers from the pulsar surface. The explosion, which astronomers classify as a Type 1 X-ray burst, released as much energy in 20 seconds as the Sun does in nearly 10 years. The details that NISA captured on this record-setting eruption will help astronomers fine-tune their understandings of the physical processes driving these thermonuclear flare-ups. A pulsar is a rapidly spinning neutron star, the compact core left behind when a massive star runs out of fuel, collapses under its own weight and explodes. Pulsars spin extremely rapidly and can host X-ray emitting hotspots at their magnetic poles. Now, to be a pulsar, the magnetic pole isn't aligned with the spin axis. So as the object spins, it sweeps the hotspots across our line of sight, sort of like a lighthouse beam, producing regular pulses of high-energy radiation. This particular pulsar, which is located around 11,000 light-years away in the constellation Sagittarius, is spinning at a dizzying 401 rotations per second and is part of a binary star system. Its companion is a brown dwarf. Brown dwarfs are amazing objects. They fill the gaps between the smallest stars and the largest planets. In fact, if the largest planet in our solar system, Jupiter, was about 13 times larger than it is, it would be a brown dwarf. And the dividing line between the smallest stars, spectral type M red dwarfs, and brown dwarfs is very fuzzy. In fact, many objects which start their lives as red dwarfs end up becoming brown dwarfs once they've burnt off enough mass. Now, in the system we're looking at, a steady stream of hydrogen gas is flowing from the companion brown dwarf towards the neutron star, and it accumulates in a vast storage structure called an accretion disk. Gas in the accretion disk doesn't move inwards very easily. But every few years, disks around pulsars like this become so dense that a large amount of the gas becomes ionized or stripped of its electrons, and that makes it more difficult for light to move through the disk. And this trapped energy then starts a runaway process of heating and ionization that traps even more energy. The gas becomes more resistant to flow and starts spiraling inwards, ultimately falling onto the pulsar. The hydrogen raining down onto the pulsar's surface forms a hot, ever-deepening global sea. At the base of this layer, temperatures and pressures continue to gradually increase. Eventually, the hydrogen nuclei fuse to form helium nuclei, which produces energy, the same process that works in the core of a star. Meanwhile, this helium settles out and builds up a layer of its own. Once the helium layer is a few meters thick, the conditions allow the helium to fuse into heavier elements such as carbon. This causes the helium to erupt explosively, unleashing a thermonuclear fireball across the entire pulsar surface. Astronomers employ a concept called the Eddington limit, named after the English astrophysicist Sir Arthur Eddington, to describe the maximum radiation intensity a star can have before that radiation causes the star to expand. Now, exactly where this point is depends strongly on the composition of the material lying directly above the emission source. And in the case of our pulsar, the authors are apparently seeing the Eddington limit of two different compositions in the same X-ray burst. As the burst started, the NISA data showed that its X-ray brightness leveled off for almost a second before increasing again at a slower pace. The authors interpret this so-called stall as the very moment when the energy of the blast built up enough to blow the pulsar's hydrogen layer into space. The fireball then continued to build up for another 2 seconds before reaching its peak and blowing off the more massive helium layer. The helium expanded faster, overtaking the hydrogen layer before it could dissipate, and then slowed, stopped, and settled back down on the pulsar surface. Following this phase, the pulsar briefly brightened again by roughly 20% for reasons the team don't yet fully understand. During the pulsar's recent round of activity, NASA detected another, much fainter X-ray burst that displayed none of the key features observed in the August 20 event. In addition to detecting the expansion of different layers, NASA's observations of the blast also reveal X-rays reflecting off the accretion disk, and they record the flickering of burst oscillations, X-ray signals that rise and fall at the pulsar spin frequency, but which occur at different surface locations compared to the hotspots responsible for its normal X-ray pulses. This report from NASA TV.
On August 21st, 2019, NASA's NICER telescope on the International Space Station observed its brightest X-ray burst to date. The flare-up came from SACS J1808, a binary system about 11,000 light-years away. Here, a pulsar, a rapidly spinning neutron star, draws gas from its companion, an object called a brown dwarf that is larger than a planet but less massive than a star. Hydrogen gas from the brown dwarf forms an accretion disk around the pulsar. Every few years, the disk becomes unstable. This sends a rush of gas toward the pulsar that makes it brighten in X-rays. The pulsar's super-strong magnetic field sweeps up the gas and channels it to the object's surface. Hydrogen nuclei falling to the pulsar's surface fuse together, producing energy and forming helium nuclei, which settle out below. This process is similar to what happens inside our Sun. Then, when the conditions are just right, the entire helium layer ignites in a brief but intense thermonuclear fireball. Astronomers call this a Type 1 X-ray burst. Here's how it happened. The explosion first blows off the hydrogen layer, which expands and ultimately dissipates. Then, the rising radiation builds to the point where it blows off the helium layer, which overtakes the hydrogen shell. Some of the X-rays emitted in the blast scatter off of the accretion disk. The fireball then quickly cools, and the helium settles back onto the surface. It was all over in 20 seconds, but NICER data clearly show important details that haven't been seen together in other bursts. This will help scientists better understand the extreme physics of these eruptions on accreting neutron stars.
You're listening to Space Time. Coming up, rewriting the textbooks on the origins of globular clusters, and later in the science report, researchers warn of climate tipping points which could lead to rapid runaway climate change. All that and more still to come on Space Time. Astronomers have discovered something that shouldn't exist, relatively young globular clusters, a finding which contradicts the idea that all globular clusters are ancient objects. The observations, reported in the journal Nature Astronomy, show that several thousand globular clusters around a huge elliptical galaxy at the centre of the Perseus Galaxy Cluster were only formed in the past billion years or so. The study, led by Dr. Jeremy Lim from the University of Hong Kong, is based on data from NASA's Hubble Space Telescope. Globular clusters are tightly packed spheres containing thousands to millions of gravitationally bound stars. These stars were all originally formed at the same time from the collapse of the same molecular gas and dust cloud. They're thought to be among the oldest visible objects in the universe, having formed soon after the universe began 13.82 billion years ago, and probably around the same time or perhaps even before the very first galaxies formed. Since their birth, globular clusters have remained relatively unchanged, apart from the aging and eventual death of the individual stars within the cluster. As ancient pristine witnesses to the formation of galaxies, globular clusters were thought to provide vital clues about how infant galaxies form and evolve over time. If only scientists knew how globular clusters themselves were formed and accumulate around galaxies. We know that our own galaxy, the Milky Way, is surrounded by about 150 globular clusters, and bigger galaxies have many more. The largest numbers of globular clusters, over 10 to 20,000, are found around giant galaxies at the centres of galaxy clusters. Galaxy clusters contain hundreds to thousands of galaxies all bound together by gravity and infused by hot plasma up to 10 times hotter than the centre of the Sun. This ionized gas far outweighs all the stars in the galaxies comprising the galaxy cluster. Now, because stars need relatively cool molecular gas and dust clouds to form, the newly discovered younger population of globular clusters formed in a complex filamentary network of cooler gas that extends to the outer reaches of the galaxy. This cool gas is thought to have precipitated from the hot gas that infuses the entire Perseus Galaxy cluster. The density of the hot gas, hence the rate at which this gas cools, rises rapidly towards the centre of the cluster. After they form, the younger globular clusters are no longer bound by the network of cool gas, and they tend to migrate inwards onto the galaxy, while the older globular clusters are distributed more randomly throughout the galaxy, owing to their random scatterings off each other during their orbits around the galaxy. The discovery of younger globular clusters suggests new ones are constantly being formed, which would explain why large galaxies have so many of them. It could also explain why globular clusters around large galaxies exhibit such a broad range of colours. The colours of globular clusters change progressively from blue to red as they age. That's because the more massive and bluer stars die first, leaving the less massive redder stars behind, and hence their broad range of ages results from a broad range of colours. You're listening to SpaceTime. Still to come, scientists think aerogel shields could be the answer to making plants grow on Mars. And scientists have developed biodegradable plastic bags out of banana plants. All that and more still to come on SpaceTime. An Ariane 5 rocket is blasted into space carrying 2 new telecommunications satellites into orbit. The mission launched from the European Space Agency's Kourou spaceport in French Guiana, carrying the TBAR-1 and Inmarsat GX5 spacecraft.
À tous de DDO, attention pour les décomptes final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage AP, décollage. Les paramètres à bord sont normaux.
Well, that is a spectacular sight. Ariane 5, flight number 250, the 250th Ariane vehicle to launch from the pad here at the Guiana Space Center, blazing a trail across the equatorial skies. Flying supersonic, faster than the speed of sound, and the vibrations are reaching us here at the Guiana Space Center.
Les paramètres à bord sont normaux.
He's telling us that everything on board is going according to plan. We're flying out east across the Atlantic. TBAR-1 and GX5 have started their journey. And he's telling us the propulsion is nominal. Right now, the boosters are doing all the work. They're those 2 big solid tanks on each side of the launcher. Once they burn their propellant, they separate and fall away.
Des étages d'accélération à poudre.
Those 2 big boosters, we don't need them anymore. They've burnt their propellant and we are shedding weight. That's the name of the game. We need to get rid of our weight as quickly as we can. And those were propelling us away from our Earth's gravity.
La propulsion est nominale.
Our altitude, we're 106 kilometers high and climbing. And we have confirmation there that the fairing has now separated. We don't need the fairing anymore because we are technically in space.
Ariane Space Flight VA250 was the 4th Ariane 5 launch this year and the 106th mission for the Ariane 5 rocket series. The 5,600-kilogram TBAR-1 telecommunications satellite was deployed into its geostationary transfer orbit 27 minutes after launch. The satellite was jointly developed by Airbus Defence and Space, who supplied the platform and assembled and tested the spacecraft, and Thales Alenia Space, who designed and built the Ka-band communications payload. It'll be used to provide broadband communication services for the Egyptian government over the next 15 years. TBAR-1's deployment was followed 7 minutes later by the release of the Inmarsat GX5 telecommunications satellite, the company's 5th Ka-band new generation Global Express satellite. Built by Thales Alenia Space, the 4,007-kilogram spacecraft's equipped with 72 Ka-band fixed-spot beams and 4 steerable beams to direct additional capacity to where it's needed. It'll provide mobile broadband services, including airline Wi-Fi and commercial maritime services across Europe and the Middle East for the next 16 years. The Indian Space Research Organisation ISRO has successfully launched a new high-resolution spy satellite into orbit. The 1,625-kilogram Cartosat-3 was flown aboard the PSLV C-47 Polar Satellite Launch Vehicle from the Satish Dhawan Space Centre on the Bay of Bengal coast. For this flight, the launch vehicle was placed in its XL configuration, equipped with 6 strap-on solid rocket boosters. Cartosat-3 is equipped with multispectral and hyperspectral imaging and mapping technology, allowing resolutions down to just 25 centimetres. The spacecraft was placed into a 509-kilometre high polar orbit. As well as the primary payload package, the mission also carried 13 American nanosatellites, including 12 Flock 4P Earth observation satellites and a meshbed testbed communications satellite. This mission marked the 49th launch of a PSLV rocket. It was also the 74th launch from the Shatishta 1 Space Center. This month, Australian Sky and Telescope magazine celebrates the birth 100 years ago of one of the great unsung heroes of astronomy, astrophysicist Eleanor Margaret Burbage, who was born on August the 12th, 1919. Joining us now with all the details is the magazine's editor, Jonathan Alley.
We pay tribute to an astronomer who turned 100 years old this year and is still going strong. Now, you've probably never heard of this person, yet this astronomer is credited with working out one of the most fundamental things about astrophysics, and that's how the chemical elements are made inside the superhot cores of stars. I'm talking about a person called Margaret Burbage, an incredible woman who forged a really stellar career, pun intended, at a time when women were, often actively prevented from participating in science. Sometimes she even had to get her husband, Jeff, who was also an astronomer, to apply for time at observatories for them both so that she could get to work there while he was off doing his own thing. She would be in the observatory doing the work. Her life story is really quite amazing. She began her career in World War II, just as World War II was starting, 1939, often working alone at night in observatories with bombs going off nearby. That's how amazing. And straight after World War II, as a freshly minted astronomer, she would give practical astronomy talks and lectures and things to undergraduate students, one of whom went on to become one of the world's most famous science fiction authors, Arthur C. Clarke. And she and her husband formed a scientific team with two other astronomers, a guy called Willie Fowler and a very famous man, some would say a renegade astronomer, Fred Hoyle. And the four of them together published an amazing seminal scientific paper, 108 pages long, about how the chemical elements are made inside stars, showing that we are all made of star stuff. That's where all the heavy elements came from. She went on to become director of the Royal Greenwich Observatory. She was president of the American Astronomical Society, two of the most prestigious roles you can get in astronomy. Yet when the Nobel Prize for Physics came around in 1983, it was given to one of the four, Willie Fowler, but Margaret Burbage and her husband and Fred Hoyle weren't even mentioned. Sexism? Who knows? Probably. She faced a lot of that during her life. She faced more than her fair share of it, though, but really stoically pressed on.
Science really hasn't been good to female scientists over the years, has it? I mean, it wasn't all that long ago when women weren't allowed to go to university and study science.
Oh, absolutely right. And even when they were, it wasn't too long ago, only a matter of a few decades ago, when, say, you were a young female scientist, and then you got married and you were expected to resign. And that wasn't just in science, of course. That was just all across the societies.
When you think about the contribution women have made to science, I mean, we wouldn't know about the different spectral types of stars that we have if it wasn't for the work done by female astronomers.
Yeah, the famous Harvard computers.
Yes.
And others. There are so many of them. There are just endless number of women who either were denied the opportunity to really flourish in science, or who did do amazing scientific work and weren't really recognised. Anyway, Margaret Burbage is an amazing example. 100 years old.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And you're listening to Space Time. I'm Stuart Gary. And time now to take a brief look at some more of the other stories making news in science this week with a science report. Scientists have now confirmed that so-called climate tipping points, thresholds that if passed could lead to more rapid runaway climate changes, could be more likely to occur than previously thought. A report in the journal Nature claims tipping points such as the loss of the West Antarctic ice sheet or the Amazon rainforest were once only thought likely to occur if global warming exceeded 5 degrees Celsius. But recent studies have suggested that some tipping points might be crossed with temperature increases of just 1 or 2 degrees Celsius, sparking a domino effect. Scientists say consideration of tipping points helps to define that we are in a climate emergency, and it further strengthens this year's chorus of calls for urgent climate action. Problem is, despite most countries having signed on to the Paris Agreement to keep global warming to below 2 degrees Celsius, the world is nevertheless on track for a rise of at least 3 degrees Celsius. That's because, despite most countries reducing their carbon footprint, the Paris Agreement allows countries like China and India to keep increasing their carbon emissions for at least another 10 years, with China alone increasing its annual rate of CO2 emissions by an amount greater than Australia's total yearly emissions of the greenhouse gas. Scientists warned that more than half of the tipping points that could push the planet towards a hothouse Earth and threaten human civilization are now active. The active tipping points include the extensive loss of Arctic sea ice and ice sheets in Greenland, West Antarctica and the Wilkes Basin of East Antarctica, the thawing of permafrost and the destruction of boreal forests and the Amazon rainforest. A new study warns that noise from boats and other vessels is reducing the ability of migrating humpback whales to communicate with each other, resulting in fewer social interactions between different whale pods. The findings, reported in the Journal of the Royal Society, shows that as noise from vessels becomes louder, the calls from humpback whales are more likely to be masked, meaning fewer groups will receive these signals. The researchers say that while these changes are currently short-term and localised to specific regions, increases in vessel activity due to tourism and coastal population growth may cause more sustained changes along humpback whale migration paths. A new study suggests that a combination of small populations, inbreeding, and random fluctuations in birth and death patterns may have created a sort of perfect storm that helped wipe out the Neanderthals. The role that Homo sapien, that is modern humans, played in the demise of the ancient hunter-gatherers has long been disputed, but scientists agree Neanderthals disappeared around 40,000 years ago. Now, a report in the journal PLOS ONE says scientists tested 3 population sizes, simulating how these groups would change over a 10,000-year period. They found that inbreeding alone could wipe out populations of 1,000 or less. But the simulations also showed how additional fluctuations in births, deaths and sex ratios could have helped wipe out far larger groups. Shields made from a thin layer of special foam called aerogel could be the answer to making plants grow on Mars. The findings, reported in the journal Nature Astronomy, suggest silica aerogels could be used to build greenhouse-style habitats on the red planet. They say the aerogels, which are substances similar to super lightweight polystyrene, would only need to be about 2 to 3 centimetres thick in order to allow the sunlight to get in but keep harmful radiation out. Additionally, the walls would provide enough heat to keep liquid water from freezing. Researchers say it's an important development for future human activity on Mars, but they acknowledge that further research is needed to better understand the risks of potential Martian life way before aerogel greenhouses are built. Scientists have come up with a way of making biodegradable plastic bags out of banana plants. Banana palms are usually cut down and mostly discarded after each harvest. A terrible waste as only 12% of the plant, the fruit, is used. Scientists with the University of New South Wales were interested in the pseudostems, the layered, fleshy trunk of the plant, which would be a valuable source of cellulose. Cellulose is an important structural component of plant cell walls. It could be used in packaging, paper products, textiles, and even in medical applications, such as wound healing and drug delivery. The researchers first converted the pseudostem material into a fine powder, then isolated the nanocellulose, which could then be made into a range of materials. When processed, it has a consistency similar to baking paper, but it could be made in a range of different formats depending on thickness. The end product is non-toxic and totally biodegradable and recyclable, taking about 6 months to completely break down in the soil. The team are now looking for an industry partner who could look at how the process could be upscaled and how cheap it could be made. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcasts, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audioboom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web that I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram. On Facebook, just go to www.facebook.com/SpaceTimeWithStuartGary, and you can also find us on the SpaceTime with Stuart Gary YouTube channel. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.